Hello, everyone. I hope everyone had a good test week and every test went well. We're going to get back into some more new topics this week, even though it's a short week. But let's get started. We're going to talk about electron configurations today. I want to start with just a little bit of review. So right before our test, we were talking about electron orbitals. So we said that there's 4 different kinds. We said that they each have a different subshell, and they were our S, P, D, and F. We even watched a couple of videos that showed how they looked in 3 dimensions. So we have our S, which looks like a sphere or a circle, our P, which kind of looks like dumbbells, or I almost think of balloons tied to each other. D also just maybe if we had a couple more balloons, and then F gets a little bit hard for me at least to understand. So we remember that each row has a certain number of electrons, and each subshell has a certain number as well. So of course our S's, as we learned, can only hold 2 electrons. Our P's can hold 4, our D's can hold 10, and our F's can hold 14. So that's just a little bit of the shape. We also learned how to fill in some of our electrons into our shells. So a quick reminder is we fill subshells one at a time. So each of our subshells are labeled. We have our 1s, our 2s, our 2p, 3s, 3p, 4s, 3d, 4p, all the way up. So electrons always fill the lowest unoccupied shell first, and then our arrows go in different ways. So if we were to do this, like we've shown before, we would have one arrow going in one way and another all the way up. It's interesting when we get to our P shell though, because we have 3 options, they're going to fill all 3 before going and filling in another one. Also, an important note is when we're looking at our increasing energy, once we get to our D shells, we're going to have 4s and then drop down to 3d and then go back up to 4p. So 5s, 4d, 5p, 6s, then we put in our F part, 4f, 5d, and all the way up. So our D's and our F's are a little different. Our D's are always 1 less than the row they're in, and our F's are always 2 numbers lower. But I'll explain that a little bit more as we keep going. So remember, for when we are writing things down, anything that's underlined, I really want you guys to have written down in your notes. I think that's the most important thing to remember. So our electron configuration tells us how many electrons are in each subshell. So each new row is a new number in front of the letter, and each new electron adds to the exponent. So for example, our hydrogen would have a 1s1. Our iron, Fe, has a full electron configuration of 1s2, 2s2, 2p, and so forth. So the letter tells us the subshell, the exponent tells us the number of electrons in each subshell, and the electron shell is the number. So if we were to add every single one of the exponents, we would have a number that is equal to our atomic number. So just some things to maybe help understand or draw some information back to what we've already learned. So another example, this one I think you guys should write down just to understand what it looks like a little bit. We have our sodium. So if we had sodium, it would be a 1s2, 2s2, 2p6, and 3s1. But really, what do these mean? Oh, I am sorry. This is a very blurry picture. I was hoping that to be clear. Just again, tying this back together. So we have our element, which is lithium, and it has 3 total electrons. So when we filled in our arrows in our orbital diagram, we would have 2 electrons in our 1s and 1 in our 2s. So our electron configuration would be this. We also can see as we go from boron, carbon to nitrogen that each one of them fills the next available unoccupied shell in our orbital for our 2p. And they're all the same except this last exponent. So our boron has a 2p1, our carbon has a 2p2, and our nitrogen has a 2p3. Then when we get to the end of our row, this is the neon is a noble gas, so it's on the far right. we have a full P shell. So everything is stable and happy, meaning we have 2p6, and then we go to our sodium, which we just wrote down, and it's back to our next S subshell. So this is important stuff to remember. The large number in front tells us what row we're in. The S tells us what type of subshell, so either S, P, D, or F. And the exponent tells us how many electrons are in each subshell. But how do we know how to write them? Let's first find each subshell on the periodic table. So let's always use our periodic table to try to understand how to do things. So for this, these are what our periodic table looks like. When we look at this block, it's our S block. So this is really hydrogen and helium is our 1s, 2s, 3s, 4s. This block over on the right is our P block. Then we have our D block and our F block. But an easier way to look at it is this periodic table that we have. So we have our 1s1, which is our hydrogen, our 1s2, which is our helium. And then we have all of our S blocks down here. All of our P blocks over on the right, our D blocks, and our F blocks. Again, when we're looking at our row, it's very, very straightforward. When we have our first row, it's 1s1, 1s2. Our second row, 2s1, 2s2, 2p all the way through 6. 3s all the way up to 2, 3p all the way to 6. But then our fourth row, when we get into our D block, it gets a little tricky. So we have our 4s2, and then we go down to 3d. That's just because the energy of our D subshell is a little bit lower. So instead of having a 4, we're going to put a 3. And they have all the way up to 10, and then our 4p6. So that's how we can kind of use our periodic table. Most of our periodic tables don't have it nice and easy set up like this, but this is the pattern that we would see. Another way to do it is we can follow our periodic table just like we just did. We can also follow this pattern on the side. So if we make a nice little chart with our 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, and so on, it can help us remember which one of these is a little tricky. So if we write them out very simply in lines like this, each number having a different line, and then kind of go in a diagonal zigzag, that means that we would start with our 1s, and then go to our 2s, then our 2p, our 3s, then our 3p. After our 3p is our 4s, but then we go back to our 3d for our D block, then our 4p, our 4s, and then back to our 4d for our D block, our 5p, 6s, and then we go all the way back to our 4f. So we, just like these arrows show, we kind of go back on ourselves all the way through. It's another way just to follow our periodic table, but sometimes, or most of the time, I should say, our periodic tables don't have them nice and laid out like this. They look like the ones we've seen before. So to remember just exactly when we have to go from a 4s to a 3d, or a 5s to a 4d, or even a 6s to a 4f, we can use this nice little pattern. So I'd love for you guys to write this pattern in your notes. So again, we're going to start the first part of our pattern, or it's almost like a pyramid, with this being the top, and going back down is our 1s, 2s, 2p, and then even draw some of the arrows in to help you remember that's how we use our pattern. So I personally have just memorized the orders, but I feel like this is a great tool to use, but whichever works best for you. If you can simply look at a periodic table and understand where everything goes, that's awesome. If this helps you to remember, please use this as a helpful tool. So let's try this one together. So if we're looking for silicon, which is Si, so let's remember where our blocks are. We have our S blocks mainly over here, but also including helium, our D, our P, and our F blocks. So silicon would be right here. So if we wanted to write silicon out, it would be 1s2, so 1s2, 2s2, 2p6, because we have all of those filled, 3s2, we have all those filled, and then a 3p2. So let's try some more examples. And I want you guys to pause the video and definitely try these on your own, please, and then continue going and see if you got them right. So for oxygen, magnesium, and bromine, what would be your full electron configuration? So please pause the video. All right, hopefully you guys have been able to get through this on your own. So our oxygen would be a 2s2, or sorry, 1s2, 2s2, 2p4. Our magnesium would be a 1s2, 2s2, 2p6, 3s2. And our bromine would be a 2s2, or 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 5p, 3p5. Wow, that's a lot of things to write. That's really hard. So there needs to be a better way. So there is, it's called the condensed electron configuration. So this way is just a little bit of a shortcut. It's important to know how to do our full electron configuration, not only because I'll ask for it on our tests, but because it's a very similar process to do our condensed electron configuration as it is to do our full electron configuration. So with this one, we start at our nearest noble gas. So as we remember from our last unit, our noble gases are this column on the far right, and then we just continue the process. So for example, if we wanted to do iron, which is actually done in this picture, it's right here on our table. So we would start with this noble gas, which is argon, and put it in these brackets. So argon, and then we just go through our normal next lines, which would be 4s2, and then 3d6. So it's very similar to before. Oops, I had an interesting bracket there, and there too. So another good one, and that shows the simplicity of which this can be, is our sodium. So our sodium is right here. So our last noble gas that we covered was our neon. So it would be neon and then 3s1. So rather than writing out as much as we did for bromine or magnesium, we can cut off the first beginning part and just write our last noble gas, which helps us a lot. We are only writing one line rather than possibly 6 or even 7 lines of the periodic table's full electron configuration. So condensed electron configuration is really helpful. Let's try this one as well by ourselves. So please again pause the video, see if you can do this. If you have to flip back in our slides, open up the slides in a separate tab so you can look at our good periodic tables, please do. But our answers for beryllium, would be helium 2s2. So when we look at, wow, I should have put another table. So when we look at beryllium, our last noble gas would be helium, and then we would just continue in this line. When we did sodium, our last one was neon, and we just continued in our line. So it is much shorter, and personally my preferred way. But then another example, when we do nitrogen, we do helium, which is our last noble gas, our 2s2 block, and then 2p3 block. And then our last one was cobalt. So when we did cobalt, it was our neon was our last noble gas that we covered, and then 4s2, and then 3d7. So I hope some of those examples helped you see how we would write our full and condensed electron configurations. Excuse me. If you have any questions, please let me know. I will be posting a homework for day 2, and I encourage you guys to use this presentation to help you along through doing that homework, especially some of these periodic tables that I have helped with, and please watch the video which explains the homework out. But this will be a big, very, very important tool to help you kind of understand and learn these electron configurations.